Thank you so much for coming and for joining us online. Today, it's a pleasure to welcome back Dr. David Verbich to McGill. A couple of years ago, not too far, he was sitting here as a student. Now he is a director after doing a nice trip around North America, going to California, leading Stantec office over there, and then coming back to Canada. And now he is gonna talk to us about his work on electric buses and how he has been developing that work around the world.
Yeah,
It's a pleasure to have you back, David.
thanks for having me. Thanks for the invite. It's great to be here with you all today. Thank you so much. I'd like to keep this informal, so if you have any questions throughout, just ask them. The folks online, I'm not sure how you.
They posted online on the chat, and then I asked them the question.
Okay, awesome, thank you. So the way I structured this discussion is really to look at zero-emission vehicles in terms of why are we pursuing that as a way to tackle climate change, and what are our goals by adopting zero-emission vehicles, or ZEVs. And a lot of the work I do at BetterFleet is trying to work with private and public actors on achieving that goal by creating strategic plans, by giving them analysis and feasibility, giving them recommendations, and trying to really educate and help them understand how to get there and how to plan for zero-emission vehicle adoption. So that's how I've structured this. Again, I'd like to keep it informal. If there's questions or something's unclear, please ask me to just interrupt me anytime. So as I'm sure you're all aware, greenhouse gas emissions, especially from transportation, contribute quite a bit to total greenhouse gas emissions, nearly a third throughout North America. And a lot of that, or most of that, is road transportation, trucks, cars, buses, different types of vehicles. And of course, as we're seeing now, it's contributing to climate change and extreme weather events that we're seeing. And then the emissions, or the particulate matter in the emissions and other types of contaminants, are really, noxious and hazardous to respiratory health, cardiovascular health, and can really have been contributing, research has shown, to thousands of deaths prematurely, really annually, because of the air quality. And beyond that, when we start thinking about other externalities, we think about the noise pollution coming from, internal combustion engine vehicles and motors. And I think one thing that often gets forgotten is that a lot of the burden is really on these marginalized communities, lower income communities, racialized communities, where ports are located, truck depots, bus depots generally tend to be located in lower income areas, and a lot of that cost and that burden is on these marginalized communities. So there are a lot of reasons why we want to lessen the impact of these greenhouse gas emissions from transportation. And of course, there are several ways of doing this, and I think it's not really one of these, it's all of these that can be explored or pursued to lessen the impact. So mass transportation, obviously mass transit, is a key way by reducing the amount of single occupancy vehicles. But of course, we know that most of the buses and transit in North America vehicles are powered by diesel fuel. So there are obviously ways of decarbonizing that transportation. The SDM, for example, has several electric buses, other transit agencies in Canada and the US. Transit doesn't work for everybody, so there's other modes, right? Active transportation, cycling, walking. Again, that's not for everyone in all instances. Travel less, right? Telecommuting, that's also a great option, for example. So, but again, this is not always possible. So we have, there are, especially in North America, the reality is that there will be folks that are going to drive, right? So we're looking at alternative fuels, basically battery electric vehicles or hydrogen fuel vehicles that basically have zero tailpipe emissions, I should say. And they're very quiet because they don't have the internal combustion engine. And interestingly, they require less maintenance because there's fewer moving parts, which can help lower the costs of operations of these vehicles. But I'm not going to gloss over the fact that, there are some issues that we have to think about, namely the carbon intensity of the energy sources, right? The carbon intensity of the grid. Is there an issue?
No, there's something in the Zoom, but that's.
Oh, okay. The carbon intensity, right? So here in Quebec, Hydro-Quebec, we have hydroelectricity, which is pretty low on the carbon intensity scale, but then, there's parts of the US that's still burning coal to generate electricity. So if you move to all electric fleet, using electricity, that's pretty dirty. So that's one of the key considerations. And the other one is mining for the battery materials, right? And so that supply chain is also has some work to be done to make it more sustainable. But I think, on the whole, when we take all these activities together, they do point us in the right direction to lower our the burden of greenhouse gas emissions from the transportation sector. And EV adoption has been ramping up. So these charts from Bloomberg, recent Bloomberg publications, show you the increase of passenger EV sales by market in different places in the world. And maybe not surprisingly, China is, far and away running away with it, contributing more than half. Europe, also a leader. US contributes quite a significant amount. Canada, obviously a little amount there. And then, on the flip side, as I was mentioning, it's not necessarily as easy as just buying an electric vehicle. We got to think about the fuel source. So public chargers, especially development of that robust network, is also important to speed up the adoption. And you can see from this graph here that we see that the number of chargers is also increasing together with the EV adoption. So really this adoption has been spurred, and I'll talk more about Canada, US, given the market, given the audience, that a lot of there's policy at the federal and provincial level to spur the adoption or encourage that adoption. So for example, at the federal level here in Canada, there's a target to have 100% of all vehicles sold by 2035, light duty vehicles sold, be zero emission vehicles, with some interim targets. In the US, California has a similar rule or adopted that pioneering rule a few years ago called Advanced Clean Cars 2, which again, by 2035, 100% of vehicles they want to sell, be sold in California are zero emission vehicles. And several other states like New York, Washington, and Oregon have adopted similar rules. As I mentioned, provincial targets, there's also some federal guidelines in the US. Obviously now that's in flux with last week's election. But perhaps not surprisingly, a lot of the news is that EVs are more expensive, right? So one way that governments are helping to adopt that is by providing offsets through incentives or funding. So there's funding for consumers to rebate those purchases. And then there's also more, funding for larger deployments for fleets, government fleets, private fleets, both in Canada, such as the ZVIP funding, which is really looking to help decarbonize fleets, like public transit fleets can use this to get chargers. In the US, it's called NEVI funding. There's also FTA's LONO emission program for buses, for transit agencies. So there's this incentive, and part of the work I do at BetterFleet is to work with different stakeholders to identify the funding sources that they could use, help them apply for it, so that they can start building out their infrastructure, for example, or buy buses, or understand the economic and business case around that, so that they can put in a strong grant, for example. So there's this momentum, barring what happened last week, towards more zero emissions to help reduce the impacts of that GHG emission from transportation. So as I alluded to, a lot of the work I do at BetterFleet, which is a company that was founded in Australia in 2016, that's where we're based, is really working with fleets all over the world, complex fleets, to help them understand from planning through to implementation, through to management, how to get their fleet to be decarbonized, how to get to move strategically to zero emission vehicles. And through this, it's a combination of modeling, planning, strategic analysis, management of vehicles and charging resources, and really a lot of stakeholder engagement, to be honest, because a lot of it is it's a challenge, and every jurisdiction has its own complications. So I'm going to walk through a few different pillars of what we do at BetterFleet, of what I do in my role. One thing that I'll focus on is our work that we do with transit agencies throughout the world in terms of helping them understand their bus operations, what that could look like as zero emission, what's feasible given the current technology, what sort of technology they would need to adopt, really to understand what that case is, how to get to zero emission vehicles, especially if there's mandates. For example, California, by 2040, 100% of transit agencies have to have all their fleet be zero emission vehicles. So I'll walk you through a case study of how we do that type of work. And really what we're doing here is we're using our tools that we built as a company. It's called, one of the tools is called BetterFleet Plan. And it's this online software service that is used to model zero emission bus operations. So really try to understand what the real world expected operating range is for electrification. So bus manufacturers produce specs and they say, the bus can go this far, this many kilometers, this many miles. But we know that, for example, depending on weather, depending on the bus passenger load, other factors, traffic, that will impact your fuel economy. So we need to forecast that. We need to understand what the impact is so we can really predict what that range is and how many buses they need, for example, impact on budgets, on operations, help them develop specs for buses and chargers. And then I think what's really cool is, and I'll get into that, is forecast electrical needs, because it's not just as simple as when you buy diesel buses, you have a diesel fuel tank that you can fuel up, you need that electricity, you need the chargers, and a lot of that is a large requirement that needs coordination with your utility. So the key process we use for this BetterFleet Plan tool is several inputs from the bus manufacturers, including bus specs, so that we know what the physics is like of the buses, route information, traffic information, weather information, information from the bus transit agencies, such as route schedules, dispatch information. And what we're doing then is we're trying to emulate or create a digital twin of what their operations are as internal combustion engine vehicles, and then forecast what it looks like, what it could look like if there's zero emission vehicles. And what that gives us is an understanding of energy consumption, what sort of routes are feasible, how much mileage you can get, and even total cost of ownership. And some of these outputs are examples. I know it's really small and hard to see, but what this is showing is that we can break down the results of the zero emission bus modeling to the route level. We can understand, which routes are feasible, how many of those trips are feasible by looking at how much energy is being used along the route. Then we can aggregate it up to the information on the right here to look at bus depots, so we can see how much energy and how much power is required at the depot, what kind of charging profiles we're expecting of the buses, so we can understand where and how and when we want to charge the buses to minimize the energy costs. And so this process, as I mentioned, takes scheduled data provided by the transit agency, clean it and validate it and use it in the BetterFleet Plan model. We test a range of temperatures because HVAC use impacts operating range. So somewhere that's always mild is not going to have so much of a variation in range, but somewhere like here where you get 30 degrees in the summer and minus 30 in the winter can have quite a dramatic impact on the operating range because of how much heating or cooling you're using on the bus and the energy from the battery. We also test different configurations, so bigger batteries, smaller batteries, maybe bigger buses, smaller buses, really try to figure out what the best use case is for the transit agency. And then we also do some financial modeling to understand the costs and incremental costs of adopting zero emission vehicles to really help explain this to stakeholders and decision makers. So I'll just walk through this, highlight the key elements at a high level. So our tool intakes all this data in terms of schedules that are in standardized format called GTFS from bus agencies. So that's really looking at the bus schedule. Then we also look at the vehicle schedule. So trying to understand how many vehicles are on the road at any one time for how many hours and so on. We import all this data together with, as I mentioned, bus specs. So we're looking at different types of buses, their dimensions, trying to understand their weight, their power usage, for example. And then, as I said, weather data, traffic data, topography, and other factors to really say, okay, if we modeled, if we forecasted how your bus, an electric bus would perform on your routes, is it successful? What does that energy requirement look like? And so here, for example, we have thresholds. So kind of like a gas tank, when you have a battery electric bus, you want to return to the bus depot with 20% state of charge, like your phone, you don't want to kind of go below 20% to preserve the health of the battery. And then when we're looking at fuel cell, hydrogen fuel cell buses, you generally look at 5% of the fuel tank remaining. So again, kind of like a fuel gauge on your vehicle. So we put all this together, and then we start doing the analysis, start doing modeling and refinement, and then we can work with the transit agency to work through the results and explain what they look like. So what I'll show you here is an example of a transit agency we worked with in the Midwest in the US. And what they really wanted to understand was, well, what are their options? Given their routes today, given their service today, what propulsion system best fits their needs, right? So what we did, we started off with the base case, which is basically a standard battery electric bus that has a 450 kilowatt hour battery. So that's pretty much baseline. We modeled two scenarios. The graphs on the bottom right show you an example of a route profile over time. And the gray shaded areas show elevation, because elevation is an important factor. As you can imagine, when you're going uphill, you're using a lot more energy. When you go downhill, you can have some regenerative braking. And then the red line shows you the state of charge. So, you're starting off at 100% at the beginning of the day. And as you continue along your bus route, this is 150 miles or so over the course of an 8-hour day, for example, you can see that the energy usage, the energy state of charge of the battery goes down to about 40% when you're at 59 degrees Fahrenheit, which is about 15 degrees Celsius. As I mentioned, we model also colder days, so we understand that range of impacts on the battery and impact on feasibility. And you can see on a 10-degree day, which is minus 15 Fahrenheit about, you can see that the state of charge dips well below 20%, and in fact, it's just not feasible. So the analysis here shows that this run or this block, the way the bus operates on this schedule, isn't feasible with the battery electric bus of this configuration. So you do that for all the routes, and we aggregate the data in that table at the top, and you can see that on a moderate day, you have 76% of your bus routes or bus blocks passing. And then if you're operating on an entirely cold day at 10 degrees Fahrenheit, you get 32%. So clearly this is going to be a challenge. So we look at other ways to help, or in some instances this would be okay because some agencies don't experience a 10-degree day. But here in the Midwest, you have to plan for this. So we look at other solutions or other alternatives. And one way is looking at a longer range bus, i.e. a bus with a larger battery. So this one is 675 kilowatt hours. So we run that same analysis, and you can see from the 59-degree day, it's a 97% pass rate. And then even on the 10-degree day or the minus 15 day, we're improving that pass rate again. So we have more energy on board. We're able to go further. We're able to complete more service. So that's already telling us, okay, for this transit agency in particular, they're going to need larger batteries. They're going to need buses with larger batteries. But of course, this doesn't get us to 100%. So there's another mechanism that we can look at, and that's charging on route. So not just charging at the end of the day when the buses come in and they're empty and you plug them in, but charging during the course of the day when the bus is on route with these pantographs. I don't know if any of you've seen them. There's one down at Square Victoria. The STM has one. Essentially what this does is that it tops up the bus throughout the day. So it gives it like a little boost. And I don't know if you can sort of see on the right, the pantograph charging, you see there's like a jagged, the line is kind of jagged. Sorry, it's small, but basically you sort of increase your state of charge every time you top up. And so this is one mechanism, but as you can imagine, it requires more planning. It requires more infrastructure because you've got to build these pantograph chargers, sometimes on public domain, things permitting and all that sort of fun government stuff. So, but as you can see from modeling impact, especially with the larger battery, you're able to increase that from, instead of having it be 62%, you can increase that to 87% on a 10-degree day. So there's that ability to modify or improve through this pantograph alternative. And maybe you say, okay, well, why don't we just keep increasing the battery size? And to a certain extent, that is the case, that is feasible. But at one point, the batteries themselves become so big and so heavy that you actually expend a lot of energy just moving the batteries. So you're kind of capped on how much battery capacity you can have because of the weight. Although obviously with improvement in technology, maturation of technology, the batteries are getting better in terms of density, so they're not as heavy, but they still have quite a bit of energy in terms of density. And so what we did here, excuse me, is we modeled out different scenarios where the battery capacity would improve. And the way that we're imagining this is that early on in your transition, you can adopt the buses that currently exist, the lower capacity buses, and put them on your shorter routes. And then as technology improves and the buses get, or the battery capacity improves, then you can start adopting them on your longer routes. And that way there's more of a fit for purpose by having them go through this transition. And then finally, there's also an alternative to battery electric buses, which is hydrogen fuel cell vehicles, which operate similarly to a battery electric vehicle, except instead of charging them, you're fueling them with hydrogen fuel, and then the buses use that hydrogen on board to convert to electricity, which powers a battery, which then powers the engine or the motor, excuse me. And what this is able to do is able to give you a longer range. So as you can see here with this modeling scenario with the hydrogen fuel cell, the pass rate, even at 10 degrees, is 91%. So you're able to really make that improvement, at least in this scenario for this transit agency, that in cold conditions, you're able to do more of your service with hydrogen fuel cell buses. But there's other trade-offs too, because hydrogen is kind of expensive. It's not available throughout the US or Canada. It's really sort of what makes sense for your environment. So for example, maybe in Alberta, where there's fossil fuels, there's more availability of hydrogen versus, for example, here or in the Atlantic provinces. And taking this all together, what we're able to do is this fit for purpose analysis. We're able to plot this out and then look at the options, as I mentioned, more buses. For example, if we're only able to do 60% of it, maybe we need to have more buses to do the routes that fail, but that means your operating costs go up because you need to hire more bus operators. Think about on-route charging, as I mentioned, hydrogen buses, bigger batteries, reblocking or rescheduling your service. And so it's really a matter of trying to fit all of this together and trying to understand which route or which mechanism is ideal for a certain transit agency. And one thing I sort of glossed over and now I want to come to is the fact that for battery electric buses, we got to charge them, as I mentioned, right? And so this can be pretty demanding. So on the graphs here on this slide, you can see what we call charging profiles, which is basically over the course of the day, when we look at all the buses at a bus depot, what happens when we start plugging them in and charging them. And what we want to do is we want to avoid this red bar called network peak, which is basically when electricity is the most expensive. So we're trying to shift that. And so what our model does is trying to understand, okay, given your constraints, given that you have to have buses out on the road at whatever time, what kind of charging mechanisms can we do? Can we delay the charging? Do we have to plug them all in and start charging them right away? Can we plug them in and then start turning on the chargers later? How can we, avoid peaks during that time when electricity is the most expensive? And then also, how can we reduce the amount of electricity we're going to need and the amount of charges we're going to need overall? Because I know it's really hard to see here, but we're talking about things like 5 or 6 megawatts of power, which is quite significant. And to put that into context, for example, for this transit agency, we estimate they would need about 6 megawatts at their depot. And when you're looking at this graph here that shows you an example, what does that mean? You can see 50 buses would be 3 megawatts. An office building is about 2 megawatts. So it's a lot of electricity. And so to help modulate that, to help control how much energy you'll need to, how much power and how much infrastructure you'll need to invest in, the other thing that I work with transit agencies on is deploying charge management software, which is basically trying to manage their resource and manage their chargers together with the electric vehicles, the routes, and try to minimize the energy you need, or optimize, I should say, the energy you need. And really, this is so, like the graph here on the right, is that we're trying to reduce the demand during peak times, and we're trying to also reduce the peak overall, kind of spread the peak. And so I'll just go through these next slides pretty quickly in terms of the charge management software that we work with transit agencies to develop and provide is really trying to predict what kind of charging schedules the vehicles need, what kind of chargers they can use, what kind of dispatch decisions the folks at the garage can make in terms of trying to understand, okay, should we send out this vehicle now, or should we hold it on, charge it a bit more, and then send it on a different route, but then another vehicle, depending on how much charge it has and how much energy it needs, can we send out that vehicle? So help with that decision making, making it automated, because as you can imagine, this can be pretty complicated when you start having 2,000 vehicles and a dozen depots. And a lot of this is based on information that we get from the trans agency, but then also predictive algorithms, machine learning to incorporate things like weather, weather forecasts. If on a colder day, we might have to charge buses more, for example, to get them out than on a milder day. And then we're also doing things like I mentioned, load management. That's really trying to minimize or optimize, I should say, the amount of infrastructure you need on site by doing things like balancing between the number of chargers and the charger dispensers themselves. So we can use it. You could use it wisely, you could use it strategically, and then have the vehicles charged during those times of day when electricity is the cheapest. And the industry calls it smart charging as opposed to dumb charging, where you just plug in the vehicle and it starts charging right away until it gets to 100%. This is really a case where we're trying to balance the load. We're trying to look at what your demands are for your site, but then also for your operations. And really it's to enable or empower the depot operator to make these smart decisions. And it goes into this case of, if we're going to plug in all these buses, if we're going to plug in all these vehicles, that's a lot of energy. And it's not necessarily wise to just build out to the maximum or to the peak requirement, but it's really trying to use this more strategically by using things like smart charging. And that brings me to my next point, right? So I showed you that graph in terms of 50 buses being, if you plug them in simultaneously and start charging them, that's 3 megawatts, which is a lot of energy. But if you can imagine now, if you're a trans agency that has a dozen depots and 2,000 buses, that's a lot of electricity. And then, of course, as I started my presentation with, more and more fleets are becoming electrified. Consumers are electrifying their vehicles at home. And so that's going to place a large strain on the grid. And in a lot of places in North America, the grid is already aging and is vulnerable and so on. So another pillar of what BetterFleet does is work with other stakeholders to look more globally or more regionally at energy requirements and try to help plan not just zero emission vehicle transitions, but work with electric utilities to help understand and plan electric grid development and build out. And so what this part kind of looks like, it looks at is trying to optimize infrastructure build out. Where do we prioritize infrastructure? How can we leverage infrastructure intelligently, in the sense that if you have a charger or several groups of chargers, maybe during the day it's being used by a school bus, for example, when it's being charged when the students are at school, and then when they go out for afternoon, the buses go out. But then during that time, perhaps there's logistics companies, when they're done deliveries, they can use those same chargers, right? So kind of optimizing it instead of just having infrastructure dedicated for each vehicle. So the other tool we use is called BetterFleet. And what this does is really look at entire systems or entire regions to understand the impact of charging and where it occurs, so that we can help plan for capital investments like infrastructure, opportunities for an electric utility company to upgrade its network. And then we can also run simulations to see what happens. Okay, well, if we change a utility rate, or if we change a policy, or if we change some sort of vehicle operations, what's the impact to that demand? Is it increase? Is it decrease? How can we optimize that? And then also in terms of control or management, like I was talking about with the charge management. And so I'll go over this pretty quickly, but what we're trying to do here is create a digital twin, or emulate what happens when we start having all these electric fleets come online. And what we're doing is we're importing data sets, including land use data, different transportation demand model data, different fleets and their operational data, obviously electric utility, network data, grid capacity constraints, and so on, all these sort of layered data sets to understand, okay, where's the capacity, where are the constraints, and then using other information like demographic information, EV adoption rates, pollution information as well, to try to predict where the investment could occur and what that impact could be. And then obviously optimizing, if you model chargers and their locations, where should they be located, for example, along a freeway system, so that we can really optimize that and then minimize the infrastructure spend. And so this goes through basically what I was just saying, and showing it in a graphical way that we layer in all this data. So on the graphic on the right, what's that's showing is charging profiles of different types of fleets, either bus fleets that charge overnight, or perhaps personal vehicles that charge during the day once they arrive at their office, for example. And then what we're able to do is we can forecast this over time as the EV adoption rate increases. And so we're able to test things like EV uptake. What happens if we put chargers along different parts of a freeway, different types of chargers, fast chargers, slower chargers. And then also try and understand what happens if we start, sharing more vehicles, for example, and decreasing the number of single occupancy vehicles. And this is helping. This helps, plan or understand the demand at different geographic levels. We can do it, pretty granularly. Here's an example in Australia where we're looking at basically at a postal code level. So we aggregate all this data in terms of demographic information, EV adoption rates, different information regarding different fleets in that area. And then what we're predicting on the right there is using all this information to understand charging profiles and really give the electric utilities an understanding of where those grid impacts could be and where they should potentially increase or invest in infrastructure. And I'll just quickly highlight some of these projects from Australia that our group has done in terms of looking at impacting 20-year forecasts for different uptake scenarios for South Australia. Interestingly, what they did here was look at different time of use rates and see how that can shift the uptake and how that can also impact the behavior or the adoption of the charging. Osgrid, for example, number 2 was another example where they were looking at more of a broader projection of what kind of energy is required at the different postal code level to, again, shape that investment or inform that investment in infrastructure. And the last 2 are similar studies in different regions in Australia, and in terms of looking at where EV infrastructure can be built out, for example, along highways or different areas, really trying to understand in different neighborhoods where those chargers could go based on predicted adoption, and then also then inform, again, that level of investment or infrastructure change. So I think my key takeaways really are, going back to why are we doing EVs? And I think the answer is because we need to mitigate those impacts from greenhouse gas emissions from carbon internal combustion engine vehicles. And it's only one way to tackle this air pollution from transportation. As I mentioned, there's all these different solutions or different ways to tackle that. And what we do is we use this modeling at BetterFleet and other places to understand the opportunities, the challenges, and the feasibility of electric vehicle adoption. And I think, what I hope to leave you guys with is that we need to be smart about energy use in terms of transportation, and it's really going to take a lot of coordination between different stakeholders and different actors like utilities, the cities, the different jurisdictions, the vehicle manufacturers, charger manufacturers, and other stakeholders, community groups, for example, really to understand where that demand is going to be and to really plan this out so that we can really manage the electricity demand, our infrastructure resources, so that we can build this out in a way that's equitable, but also leverages or optimizes, again, I should say, optimizes where we're putting all this costly infrastructure. And so that's actually one thing that we've been working on more recently at BetterFleet, is exploring this idea of EV charging hubs as a way to reduce the costs of infrastructure build out, so that this is a shared resource between several fleets. And we recently applied for a grant for that concept, and And what we're hoping to do is build out these regional master plans across the US so that we can use our grid fleet tool and then also layer in our planning tool to understand where that demand is and what kind of interventions could be leveraged to improve that rollout and to make sure that we can get there and that we can spur the adoption of EV vehicles for different fleets. So that's it. I hope I left you with the key message on EVs, and I'm happy to take any discussion or questions. Thank you.
Thank you. So you have 3 very hard questions from Professor Madhav Badami online.
3.
Yes.
Madhav.
So I'll pick one.
Okay, yeah.
I don't want it to be like a thesis exam for you with Madhav. So he talks about, he wants to ask you about how much higher are the capital operating and maintenance costs for battery electric buses relative to an equivalent diesel buses in North America?
Yeah.
So have you looked at any comparisons?
Yeah, so I mean, ballpark, the capital cost for a bus is about double, right? Give or take, depending, I'm going to use US numbers because that's what I can think of, right? So like a standard diesel bus in the US now is about $600,000. And then equivalent battery electric bus, depending on all those, configurations, can be like $900,000 if you buy a lot, right? And you have a bulk discount, or 1.2 million, depending on the configuration. So that's a big part of it, right? And then you got to invest in your infrastructure. You got to get all the chargers, have to work with your electric utility to bring in all this power. As I mentioned, 6 megawatts or what have you, right, is not an insignificant amount compared to what bus garages use now. And then the idea is that hopefully you save on maintenance costs because there's fewer moving parts. That hasn't really been played out because the costs are still there and labor is expensive, especially for unionized shops like transit agencies. And then electricity generally is going to be cheaper in theory than diesel or other fossil fuels, depending on policies, depending where you are. Like here, electricity is pretty cheap, but certain parts of the US, it's not so cheap. But relative to diesel, the idea is that will get cheaper. So while, and Madhav brings up a good point, the capital costs get more expensive, in theory, the operating costs get less. And you hope that there's some sort of equilibrium, especially as technology matures and costs for vehicles hopefully go down. And by 2030 or something, we're at parity. That's the idea. That's the hope.
Let's take a couple from inside the class and then we move to. Okay. Let's move like this.
I'll go this way.
Let's move this way.
So I imagine probably like a common critique would be that the money spent on electrifying could be spent on expanding the service of its specific transit agencies. Does BetterFleet look at kind of the environmental impact or other impacts of that transition?
Yeah, that's a great question, and we're really focused on that, on the technology, not so much service expansion or changes to ridership, which is a great point. When I used to be at Stantec, that's what we would do as well. We look at let's increase ridership by increasing frequency, et cetera. But our focus is really on the technology in terms of propulsion and GHGs. But that's a great point. A lot of jurisdictions worked in, it's like they adopt zero-emission vehicles, but it doesn't help if you got 0 riders, right? Just have empty buses that are electric. But it doesn't really help offset if people are driving instead.
Yeah, I think maybe connected to that, and you touched on this briefly, but I've already written down my questions, so I have to. But essentially, just one of the main purposes of switching to ZEVs is to decarbonize.
Yeah.
Switch on GHGs. But in certain cities, maybe other than Quebec or Vancouver, a lot of electricity is green energy. But perhaps in cities where it's a lot of the electricity is from fossil fuels, how do you reckon with that, or go about planning with those cities?
Right, yeah, and so the idea there is that we're looking at generally, the carbon intensity and looking at that impact. But it still decreases, right? It still decreases because that's generally not as carbon intense as using gas or diesel, right? So it's still there. But a lot of jurisdictions are planning to decarbonize their electricity sources too, but that's definitely a trade-off that we do look at. We look at those GHG profiles over time. And so, yeah, in some jurisdictions, you're right, it never really goes to zero, right? Even though your fleet's 100% battery electric, for example. That's a good point.
So we calculated ECO for electric buses in routes and lifespans. And they found an average for lifespans larger than 14 years. Electric buses are have a smaller TCO than the diesel ones. Is this behavior similar in other cities that you have worked in?
Yeah, that's the forecast over, 12, 14 years. Yeah, that's the forecast that because your operating expenses are much lower, that eventually you have a lower cost of ownership. But right now with the buses, as I said, being double, that's a pretty hefty piece. So you look at things like vouchers or other incentive programs, like governments have to reduce that. And then if you really want to be, creative, you throw in the health benefits, right? The costs of, premature deaths and all that. And then you throw that in on the cost side, and then it turns out the benefits look nicer. So,
I want to jump in with one online question from Brendan Himaili from Toronto.
Hi, Brendan.
You know Brendan?
Yeah.
He's asking, how does the ZEB deployment in North America compared to that in Australia and Europe, since you are involved, your company works worldwide? And he's saying, I assume that the great deployment level, sophistication, and management increases. How far behind are we in North America?
That's a great question. I think I'm not too familiar with the European side. I'll speak to a bit more of the Australian. I think it's, again, pockets of Australia are doing it. Like Sydney is pretty far advanced. Melbourne and some other areas, but so yeah, they are ahead. I can't put years. That's not. I can't really speak to that necessarily. China is the leader. Clearly, they've got these electric buses in a lot of cities, and they just have huge fleets, right? You think about Montreal, you think about Toronto, which are the biggest cities in Canada. They've got 2,000 vehicles. I think China, that's nothing, right? That's small compared to some of their big cities. So when you look at where we are, I think we're behind, but I think a lot of that is due to caution and just the amount of planning that's necessary to adopt it in a way that brings all these stakeholders on board, right? Because it's just, as I mentioned, right, it's not just buying the bus, it's not just buying a charger and plugging it in, you got to coordinate with your utility, and then that brings in other regulatory bodies. So there are other jurisdictions in the US, obviously, that are further ahead, such as one in California where that mandate's been there. And then, I won't forget that in Vancouver, right, where they have trolley buses that are zero emission, right? So they run on those trolley wires. So there are places, Seattle is another example, SF are advanced in that sense. They're not battery electric vehicles per se, but yeah, so I know I sort of skirted the answer, but we'll get there. I think we'll get there.
It's okay.
And then I'll come to one of Madhav's.
Number two, yeah.
Yeah.
A warm up, yeah. Yes,
Is
please.
there some sort of ideal network for specifically for EV buses? And if so, you usually advise your transit agency to replan that network? I guess shorter routes probably one of the things that.
Shorter routes, it's also how long your bus is out on the road, right? So the route is an important factor, but the buses do many routes, many trips during the day. They can do different routes. So, more compact cities that have shorter routes, maybe that buses that are staying out less it's a better fit for purpose for a smaller battery electric vehicle. But it is a challenge in the sense that, are we planning your bus network and your bus service around the technology, or should we plan the technology around what your city needs, right? And that's a trade-off or a challenge I think that we're still grappling with. I'm sorry, you had a second question, right? You had a follow-up.
Any other questions going around? Okay, let's go here and then I'll go to Madhav.
Why has China been so much more successful than everyone else? And is that something they're doing that could be emulated elsewhere, or is it just that they have to meet?
I think it's a lot of, and I think it's a lot of fact that they can do that centralized planning, right, where they can do a lot of that deployment. The electric vehicles are heavily subsidized by the government, right, the government businesses. So even at the consumer level, right, their EVs are much cheaper than ours are here. A lot to do with rebates or discounting because of the government incentives. And then I think, or at least I like to think is because they're seeing that the pollution is pretty bad, that they want to try to decarbonize so that they can improve the air quality. And really spur that on, but yeah, they've been a leader.
So Madhav is a big fan of you, as you know. He asked a fourth question, but I'll stop at two. If you can see me sending you thumbs up. So what are the implications, like in your software when you're using it, do you look at the wear and tear on the streets? Because you have heavier bus.
No, we don't, but that's a great point.
Yeah.
That's a great point, and in fact, it's an issue right now in California because they're building heavier and heavier buses, and there's weight limits, restrictions on a lot of roads. That the buses leaving the factory right now are challenged to be with, under that threshold because of the weight of the battery. So no, we don't do that modeling, but that's a great point.
And then that's half part of question two. He talks about the safety, road safety, because they're quieter buses.
Yeah.
Okay. A more general question: how do we tax electric vehicles? Part 2035 to replace massive revenue from gasoline and diesel tax based on vehicle weight and road wear and tear. He asked the question and he answered it.
I know. Yeah, I mean, that's a great question. I'm not a politician, so I don't have an answer. But whichever way gets your votes, I guess, is the answer. Don't tax it, I guess.
And then the last question from Madhav: of course, buses have advantages in terms of flexible operation, but wouldn't it make more sense to just run electric trolley buses on high-speed ridership lines?
Would it make sense? I think it depends where, and I think it depends how much you want to build and invest. It's still pretty electric intense, right?
Yeah.
Like the REM is essentially a trolley bus of sorts that's on a fixed guideway, but that's a lot of investment, right? So I think the flexibility is nice if you're able to change routes. I think that's another challenge of the on-route pantograph chargers, as I mentioned, right? They're expensive, you build them out. Let's say your demand changes, let's say the route needs to go somewhere else now, and it doesn't serve that location, you've just sunk $1 million+ infrastructure wise, electricity wise, in terms of investment, and now you have to relocate it or it's abandon it, right? So I think that's another challenge with the pantograph, but I can see the trolley bus, I mean, especially in those places where they already exist, but.
So that's the last question from me. I'd like to ask you about the technology and how fast the technology is moving. Because with battery electric buses, you're saying it would last them for 14 years, but how fast is the technology changing?
Yeah.
You have been working in this field for several years now, so you see how fast things are changing.
I think the cutting edge stuff it's moving fast, but I think the implementation is moving slowly, and so that's impacting what the bus manufacturers are putting out. And I say that in the sense that one of the really problems that the US and Canada are facing now on the transit agency side is backlog from the bus manufacturers. So they can't keep up with orders. So you order a bus today, it's going to come in 18 months. And that's just a standard bus. So if you're ordering all these electric buses, we have all these mandates, that's a key challenge, right? So they're able to make what they can make, produce what they can produce. And there used to be, for example, 4 bus OEMs in the US, there are 3 here. Now there's only 2 in the US, there's only 2 here. Right, so that production, it's gotten so bad that last year they had a summit at the White House, right, to get attention from the White House to work with transit agencies to understand that burden of what's going on in the bus manufacturing industry, because it's getting so bad that if the costs are outstripping the amount of money that these bus OEMs are making. I know I'm going on a tangent now, but the technology is evolving, but the reality is the bus manufacturers, there's only 2 in the US, there's only 2 in Canada. If you order, as many buses as you want, you gotta wait. And so that means your buses are on the road longer, you gotta maintain them more. And then you have, these mandates that are challenges, there's pushback now saying, even in California saying, yeah, you're telling us by 2035, we need this percentage of buses being zero emission, but we call bus manufacturer X and they can't meet it, right? They can't provide it. And it's getting so bad that, you know, if you drive them out of business, what's gonna happen to the bus? And these are good jobs, right? These are unionized jobs and good places in the US and Canada to make buses. So I went on a bit of a tangent, but I think that's something to bring up. You have a question?
I was wondering, with what BetterFleet has seen throughout like the different cities, how fast do local pollution levels change with EV efforts and kind of as a follow-up to that, to what extent has EVs improved equitability and reduction of air pollution or pollution for environment?
We haven't done too much work in sort of the localized space. That's really hard to forecast, and there's a lot of there are a lot of factors affecting that. But you know, one thing we do recommend in our projects and that cities do generally is they'll run those buses in priority communities, i.e. in communities where there's higher incidences of asthma, where there's higher incidence of pollution, lower incomes, and so on, and run the buses on those routes in particular. You had a second question?
Oh, I guess you kind of answered both.
Okay.
At the same time.
And I have a question.
Yeah, thanks for your talk, it's really interesting. I wanted to ask you, you mentioned how sometimes you look at small versus larger buses. I want to know if there was kind of like a conclusion you came to of whether it's better to have smaller buses that are less heavy, maybe more frequent service, because I know in Europe, I've seen like much smaller buses going more frequently versus here we have like large buses that are sometimes empty. And I was wondering if you had any insight on that.
So yeah, I mean, definitely have larger buses here. Even the smallest large bus is like 30 feet, which is still pretty long. But the challenge is you start getting like this this trade-off where the smaller buses are lighter and they have less battery capacity. So they'll have less like shorter range, right? So you need to plan that in a way that where you top up the buses during the day, for example, or maybe the routes are shorter, or maybe there's some sort of swap out of another bus, for example. So there's different. So the challenge there really is that your range is shorter, excuse me, on smaller vehicles, and then trying to balance that with ridership.
Thank you so much. Oh, yeah, last question.
Yeah, I just have a question. So you mentioned that there's only like 2 major bus manufacturers in Canada and 2 in the United States. What's like the feasibility of importing vehicles from overseas?
That's a good point. The one of the key factors about that is how do transit agencies pay for buses, and the way they generally pay for it in Canada. I'm going to talk more about the US, but is through federal funding. And so there's a mandate in the US that's called Buy America, which is meant to spur investment in the US. And so you have to buy buses with federal money that has a certain amount of US content. So if it's coming from abroad, China, or even the EU, and it doesn't have that US content, the transit agency can't use that money, right? So that's sort of a constraining factor. And it's somewhat similar here to a lesser extent because there isn't as much Canadian content and most of it's from the US. But so it's feasible, it's just where does that money come from to pay for it? And what sort of strings are attached to that funding?
Yeah. Thank you so much. There's a lot to think about and really appreciate that you took the time and came to us. Thanks, David.
Thank you. Thanks for that.
Thank you for those online and you can join us in future talks. Thanks. Bye now.